Right, it's,
Air pressure is the air mass in a certain location.
so the pressure, of air mass in a certain location?
Which one are you talking about? Volume, rising, percent?
Huh? Just air pressure in general. What is air pressure? Okay, so pressure in the air. I'm going to pass out to you. You have a short little reading article. It is a little less than a page. You've got 5 multiple choice questions. Right now it is 12:28. I am going to give you all until 12:38 if you all need it. So read it then. Yes, we will be going over this. So it is individual, so I should not hear or see talking. If you need help, let me know. People take a lot of bail. You want me to it's part of showing up to class prepared? Ask a classmate. I have a pen that you all can use, but you all have to pass it right. Okay, so remember, I should not hear you all talking. This is individual. You open. Yeah, stop. Check the picture back in. So, yeah, this part. Got it. So, you all want me to read? Okay.
Atoms and molecules that make up various layers in the atmosphere are constantly moving in many directions. Despite their tiny size, when they strike the surface, they exert force on the surface in what we observe as pressure. So anything you think is important, you can underline. So when they strike a surface, when air molecules strike a surface, they exert a force on that surface in what we observe as pressure. Okay? Each molecule is too small to feel and it exerts a tiny bit of force. However, when we say tiny forces in the large number of molecules that strike a surface each moment, then the total observed pressure will be considerable. Air pressure can be increased or decreased one of 2 ways. First, simply adding molecules to any particular container will increase the pressure. A larger number of molecules in any particular container will increase the number of collisions with the container's boundary, which is observed as an increase in pressure. A good example of this is adding or subtracting air in an automobile tire. By adding air, the number of air molecules increases as well as the total number of collisions within that tire's boundary. The increased number of collisions forces the tire's pressure to increase to expand in size. The second way of increasing or decreasing is by the addition or subtraction of heat. Adding heat to any particular container can transfer energy to air molecules. The molecules therefore move with increased velocity. Individual. The molecules therefore move with any increased velocity, striking the container's boundary with greater forces, surface increasing pressure. Since molecules move in all directions, they can exert air pressure upwards as they smash into the contact medium. In the atmosphere, air pressure is exerted in all directions. In the International Space Station, the density of air is maintained so that it is similar to the density at the Earth's surface. So we're on the next page, okay? On the next page. Therefore, the air pressure is the same in the space station as the Earth's surface. Back on Earth, as elevation increases, the number of molecules decreases, and the density of air therefore is less, meaning a decrease in air pressure. In fact, while the atmosphere extends more than 15 miles up, 1/2 of air molecules in the atmosphere contain the first 1,500 feet. So, question number 1, according to the text, what is pressure? So this was on the first page. In the first paragraph. On the first page in the first paragraph. What did it say pressure is? First page, first paragraph, what does it say pressure is? And then you tell me if A, B, C, or D. You said it's not A, so it's either B, C, or D. It's D. Are you sure? Look at paragraph one, where's the one about pressure, paragraph one? Paragraph one, where do you see the word pressure? You want to see? Okay, so let's go over and start to see. Good. Number two, based on the text, what is the effect of adding molecules or heat to a container? So if you add molecules or heat to a container, what's gonna happen? That is in paragraph three. Does it help you if I show you this? Paragraph three. So that would say if it's different, if it's greater or less than, this one's saying heat was less than, this is greater than, this is less than. That's the difference. Okay, Connor, paragraph three, what do you think number two is? What number two? Paragraph three. So, based on the text, what is the effect of adding molecules or heat to a container? So what happens if we add heat? Pressure increases, so which one's that? So, number three. What can you conclude about the International Space Station? So it says the International Space Station, the density of the air is maintained so that it is similar to the density of Earth's surface. So the density at the space station is similar to that on Earth. Therefore, the air pressure is the same in the space station as it is on Earth. So can you conclude that without air pressure maintenance, air pressure in the space station is different than Earth's? Is it without air pressure maintenance, air pressure is the same? So do you think the space station air pressure is the same as Earth's? Before? So no. No, so it's not B. So it's X on B. So if if they add air pressure, does that make it different than ours, or the same? Different or the same? Different. So it's not gonna be C, right? So it leaves you with A and D. Is there no pressure in the space station? Or is the space station different than Earth's? So what's that gonna be? And you okay? You good? What's wrong? We're moving my class just about every day. Okay, flip along over to the back. So, based on the text, what do you tell about the International Space Station? So is the heat or number of molecules greater than Earth's surface? Is the heat or number of molecules less than Earth's surface? Or is it the same? So we know it's not D. So you put next to D. So it's either A, B, or C. How many of you are still working? Okay. So we have to add more air density to the space station so it's the same as our right? So what's that gonna be? A or B? A, that's wonderful. Okay, what is the main idea of this text? A, air pressure is the same as the International Space Station. B, air pressure can be contained or can be increased by adding molecules. Or C, air pressure on Earth decreases as elevation increases. So is air pressure the same as it is in Earth's? No. So is the main idea that air pressure can be increased by adding molecules of heat and decreased? Think so? Okay. Or is it the air pressure is observed by the external force of atoms and molecules and it can change, unless you change by adding or subtracting molecules of heat? So you think B or D? D? Okay. Alright, everybody done? Who wants to read it? Or do you all want? Okay, I'll make it in. Peyton, you can start. After Peyton finishes her first little paragraph, you can pick who reads next.
Okay.
So you all get to pick who follows you after reading, okay?
Okay.
Alright, Peyton, you're ready.
The atoms and
Molecules.
molecules that make up the various layers in the atmosphere are constantly moving in one direction. Despite the shiny side, when they make a strike.
A surface. When they strike a surface,
When they strike a surface, they
exert.
exert a force on the surface in what we observe as pressure. Kristen.
Oh God, each molecule is too small to feel, only exerts a tiny bit of force. However, when we sum up the total forces from the large number of molecules that strike the surface each movement, then the total observed pressure can be considered.
Air pressure can be increased or decreased. One of two ways. First, simply adding molecules to any particular container will increase pressure. A large number of molecules in any particular container will increase the number of collisions with the container's boundary, which is observed as an increase in pressure.
A good example of this is adding air in an automobile tire. By adding air, the number of molecules increases as well. The total number of the collisions with the tire boundary The increased number of collision forces and higher pressure engines determines size.
The second way of increasing or decreasing is by the addition or subtraction of heat. Adding heat to any particular container can transfer energy to air molecules. The molecules therefore move with increased velocity expecting the container's boundary at greater force and is observed as an increase in pressure.
Good call.
Since molecules move in all directions, they can even exert air pressure upwards as they smash into an object from underneath. In the atmosphere, air pressure can be exerted in all directions. Go.
In the International Space Station, density of air is maintained so that there is a cumulative density on earth surface, therefore air pressure is the same in the space station as on other surface.
So from that, over there yet?
Right.
Back on Earth, as elevation increases, the number of molecules decreases and the density of air, therefore, is less, meaning a decrease in air pressure. In fact, while the atmosphere extends more than 15 miles, one half of the air molecules in the atmosphere are contained within the first 1,800 feet.
Okay, you all get up and move around a little bit?
Yeah.
Okay, A is back there, B's here, C's up here with me, D's over there. Number one, according to this text, what is pressure? A, B, C, D. A, B, C, D.
I just realized when your initials are arranged like they are on a shirt, it spells lad.
So, what is C?
The answer?
What is the answer? The force of atoms and molecules exert when they strike forces. Number two, based on the text, what is the effect of adding molecules or heat to a container? A, B, C, D.
Oh, okay. Well, I keep picking the wrong answers, I'm just changing. Well, this is embarrassing. I had B, I swear I had B.
B, right?
Where's the A?
A, B.
I swear I had D.
A's back there.
A,
Connor, what's that?
I swear I had D.
C, so you're with me.
Ah.
You're over here with me, put C. Okay, you all said B?
Yes.
Why'd you say it was B? So why does it increase? What happens when you add molecules?
It makes it faster. They move a lot faster.
They move a lot faster, which generates more energy and heat. So remember, think of it how when you move your body. When you move your body, what happens? When you're in gym, you get hot. Same thing with air molecules. Number three, what can you conclude about the International Space Station?
Oh my God, no, bro. I swear if I got all of these wrong.
I hate my life.
Mean, you're being mean.
I'm not being mean.
I had B for two.
Number three, you put A, so you're back there.
This is A, right?
Yes, back there is A. Why did you say A? Tyler?
Because it says without air pressure maintenance, the International Space Station's air pressure is different from Earth's, because in the sentence from the text, it says that with air pressure maintenance, the air pressure in the space station is the same on Earth.
Why do you think they make the pressure in the space station the same as air pressure on Earth? Riker? Is that a hand up or were you just?
It's a hand up.
Okay, so,
Whenever where you change the air pressure for long periods of time, like months in a row, it can cause like a bunch of health problems and cause your body to change.
so I just,
So if you experience different air pressures for long periods of time, then it can cause a bunch of health problems because you're evolved to go to the Earth's air pressure, and it'll cause changes in your body. Like you get shorter, taller, wider.
Gabby, did you bring up?
Yeah, could it also be for the astronauts when they come back, they can get used to the air pressure?
Kind of. So how many of y'all been in a plane before? What happens when you go up in your plane? What happens?
Your ears are like pop.
Your ears feel muffled, right? What does that do to?
The air pressure.
Change in air pressure, right?
Yeah.
So just that tiny difference, you think about what it does to your ears and stuff then. Now imagine doing that 4 or 5 times more higher up in the air. That's what your astronauts are going through. You can potentially pass out due to changes in air pressure. You will lose consciousness.
Oh
So,
yeah, I saw like whenever like a jet, like you know how like they have to do the upside down thing?
or like, you all watch Top Gun, right? We watch
Yeah.
Top Gun.
Yeah.
So you remember when they passed out because of the G-force and stuff?
Yeah.
Kind of the same concept.
9.7 G's to be exact.
Yeah, so same concept. All right, number 4. Based on the text, what can you infer about the International Space Station? About the heat and the number of molecules. Look at you go. Connor, what did you say for number 4?
A.
A? Okay. Okay, why have you all said C?
Species air pressure is different. We either had to add or subtract to get the same number.
Good. So you had to change the molecules, whether it be addition or subtraction, in order to make the pressure in the space station and Earth exact. Okay, so everybody good with that? So we don't know if we had to add or change. Does not say anything in the text about adding or changing, right, Connor? Right, King? Doesn't say anything about adding or changing. Therefore, you can't assume that you add or subtract. You've got to just say either or. Number 5, what is the main idea of this text? Leave them. Did it just talk about increasing air pressure? Because this just mentions increasing. This just mentions decreasing. Talk about both, right? Or did we just talk about air in a container? Or did we talk about air overall? Did we talk about air in a container or air overall? Christian? Overall. Overall, so it's gonna be. Okay, D, what is D, Christian?
I don't know. Air pressure is absorbed by the attractive forces of atoms and molecules, and it can be changed by adding or subtracting molecules.
Why is it D, Christian? I just told you, why is it D?
Because
Why is it not B?
This is B.
this is just talking about
It's just talking about, right?
whatever it's called.
So we're not just talking about containers, right? For C, are we just talking about elevation? No. For A, are we just talking about the International Space Station? No, so the only logical answer is D. Okay, good, y'all have C. Keep these, these are gonna be yours to keep. Y'all are going to want to keep all of these. y'all a chance to talk. So do you think air pressure changes with altitude? And do you think air pressure in Fleming County is the same or different than the air pressure that we find in New Orleans? So where's New Orleans? Louisiana.
It's on the.
Down at the very, very south Louisiana.
Did you say go?
It's going down.
So it's by
It's
the.
going down. Hey, where's that? Where's that?
Louisiana is down by Texas. That's where Hurricane Katrina hit.
It's only go from Mexico.
Yeah, it's the boot.
Oh, man, maybe it'll get right.
So do you think, come on, have a seat.
Tell me the number.
Do you think
116. What else?
the air pressure is the same or different? So these surface maps are your office key. So you can keep these. So what do y'all think? Yes, no, maybe?
Yes,
Yes, why?
because it's going down, or like, it's farther away from you. I don't even know, is Louisiana,
Louisiana is down by Texas, Christian.
yeah, it's gonna be hotter.
It is gonna be hotter. What else?
Because it's close to each other.
Kind of. So you all think? All right. First question first. Do you think air pressure changes with altitude?
Yeah.
Why?
Because you just told us that from space,
Height of
5 different times.
Taylor.
Because in the article, it says that like half of all of Earth's smaller air molecules are in the lower atmosphere. And the higher you go, the less molecules there is.
So why is there less molecules?
Because it's colder.
Of what force?
It's slowing.
gravity.
Gravity, right? Where is gravity higher? Is it gonna be closer here to where we are or up towards the sky?
Up towards the sky.
We're going more gravity as we go up towards the sky.
Towards the ground.
Towards the ground, right? Where does Earth's gravity stem from? The core, right? Earth's gravity kind of centers and essentially is based around the core. So the closer we are to the ground, the higher our gravity is going to be, right? The more gravity we have, what's going to happen to our air molecules? Huh? The more molecules we're going to have closer to us, which means the more more air pressure. Because remember, the more molecules we have, the more likely they are to collide with each other and cause those collisions, right? That makes sense? So, with that being said, do you think the air pressure in Fleming County is the same or different than New Orleans? Taylor?
It's different because New Orleans is, I don't know how many feet below sea level, but it is below sea level.
New Orleans is below sea level as opposed to Fleming County. We are about 160 to 200 feet above sea level. So our elevation is a lot higher than what it is in New Orleans. That's why New Orleans floods so much. Yes, Riker?
What exactly, how do they measure the air pressure like this? How do they do that? Like,
It was in your old weather packet.
How do they know how
if you just say instantly, I was
It starts, no, it was like yesterday, it was last
Was it like a barometer or something?
What?
Was it like a barometer?
Yes, a barometer. So same thing we use like a rain gauge essentially to collect precipitation. They use a barometer for air pressure.
But how does it do it?
We're not getting into that today. We have to explore. Okay? So remember, air pressure is the force exerted on the surface by the air above as gravity pulls it down. So I have passed out to you all a map with different air pressures labeled from across the United States on it. Using a black pencil, so I told you all yesterday, and it's been on the board since Friday, you all were going to need colored pencils, crayons, something of the sort. Using a black pencil, you're going to lightly draw lines to connect ideal values of sea level pressure. These lines are going to be called isobars. Isobars are drawn for every 4 millimeters. So, if it helps you, I would write 1 millibar equals 4 isobars. Down at the bottom of your paper.
1,000.
We're getting there. We're getting there.
So 1,000 millibars first.
That's gonna be kind of your reference point. So, on your paper, look for a value that is highlighted above Utah. Salt Lake City, to be specific. What is that value?
So 1,022.
1024, right? So your value is 1024. So starting at that 1024, you are going to draw a line from that 1024 to the next 1024 value located to the northeast. So, if you need to draw a compass on your paper, you may want to do that. So remember, north, south, east, and west. So if I say your value is northeast, which direction is it going to go? This way. After that, you are going to, so without lifting your pencil, you are going to go to the next 1024 value that's located to the south, and then the one located to the southwest before rounding off and finishing back up at Salt Lake City. When you draw your isobars and you connect it, there should be very few, if any, angles. So it should look like a circle as opposed to a diamond. Does that make sense? So isobar lines are going to be smooth with very few angles. That's a highlight right here. Mhm. Once you have, Christian, you ready? You're ready. Once you have all four of them connected, you should have what kind of looks like an elongated circle or oval over Utah. Also, the northeast, find one of the directions like that, where you go. Northeast, what direction you go. So draw a curve, like that one. So then where you gonna go? Also go southeast. We're gonna go south, southwest. You go there. Okay. So, everybody good with that? Your result should be an elongated circle over eastern Utah. That represents your 1024 millibar line. So everywhere along that line, you can expect your air pressure to be 1024, so 1,024 millibars. Does that make sense? Everywhere in that circle, 1,024 millibars. You are going to repeat that process with your next isobar value. So remember, the value between isobars is 4 millibars. So you do not see 1028 on there, right? So we are not going up. So which direction are we going to go? So what should your next isobar be? Yes, 1020. So you're going to do the same thing with your 1020s. Yes, all of your 1020s are going to need to be connected. You cannot cross over other isobar lines.
Need to go around?
And then we do that with 116.
Yes, Christian?
I got a question. Is this supposed to be more for
We're not there yet. We're not there yet. You're on the right track. You,
I was gonna
so,
I didn't even see those.
you got 1, 2, 3, 4, 5, 6, 7, 8, 1,020.
Oh, I missed one.
Isobars. Everybody good with that? Your old bell's fixing to ring. We will continue on this tomorrow. So, if you want to continue working to the bell rings, you're more than welcome. They do apparently have the bells turned off at 1:04. So tomorrow, you are going to continue this process until all of your number reports are connected with an isobar.
Air pressure.
Yes, keep your articles. They will come in handy as we start talking about climate change, all of that good stuff. Don't forget about your all's walkathon tomorrow. I think you all will have me in class. I don't know for sure we will. Okay.
Yeah, we should.
So tomorrow when you all come in, we will finish this up. And we'll kind of talk about how this ties in to the weather that we've talked about at the beginning of this year. From there? Okay, they get mixed in with papers and grapes. I can't, but I've got papers out of grapes. That's what I'm saying. I pull it out of the tray and it's lost. On accident. Everybody needs to be still at the bell. You all will not leave if everybody's standing up at the bell rings.
Hey,
Ready for squat.
Oh, yeah, that's.